advanced of a civilization as we are today, the power we can generate is not limitless, nor is the Earth's ability to cope with the pollutants generated through such processes. While this is true for our current technologies, there are still better options. Because energy efficiency and carbon emissions are an ever-growing problem, nuclear power plants offer a more suitable solution for the future. Proportionate to size of importance, I'll start with a planet big enough to hold 7 billion people first. As it stands, humanity only has one planet right now, Earth, and we're going through it as fast as we can. Carbon emissions are a human-generated product through exothermic reactions, as in the burning of fossil fuels, are harmful byproducts that damage the ozone and climate of Earth. These types of reactions are the main power reliance for the majority of the world and will not be quickly replaced. But over time, nuclear energy has a strong potential as a replacement candidate. Nuclear reactors, though large and ominous, produce little waste in the form of steam, radioactive material, and coolant fluid. Simple steam is not harmful, and radioactive waste can be reprocessed for more use or disposed of deep underground below the level of surface effect. The most important feature of a nuclear reactor is the coolant, and without a constant flow, the reactor would enter a state of meltdown. Newly discovered techniques to filter chemicals and desalinate water reduce damage to the hydrosphere, and pre-processing can turn the waste into valuable commodity products. With carbon emissions reduced and nuclear energy as the vanguard of power generation, saving our environment on Earth for future generations becomes all the more possible. Compared to a planet, one person is incredibly small, yet each and every life holds value. Nuclear reactor safety is the biggest concern when it comes to nuclear energy. The Atomic Energy Agency, the IAEA, is a group formed from many countries, including the United States, that works towards the goal of using nuclear energy as a peaceful alternative for using it for destruction. The IAEA holds safety as one of their greatest concerns and has created many guides on the standards for safety for operating nuclear power plants. Each year they spend millions of euros to ensure the safety at nuclear power plants in the event of accidents. Currently, there are more than 440 nuclear power plants spread across the Earth, yet in a span of 56 years, only 4 major accidents have been documented. Each time a major accident has occurred, the safety procedures surrounding nuclear power plants have grown to encompass the newfound risks that were cause of the disaster. While it seems very dangerous, most nuclear accidents have few to no fatalities and can be quickly shut down to prevent further incident. Even though people are small in comparison, when you look at a reactor core, the process happens at a subatomic level that is not visible to the naked eye. Nuclear reactions that take place in the core are incredibly small and just as efficient. The fuel used in nuclear reactors is uranium-235, the only isotope of uranium able to undergo fission. Fission is the process of splitting an atom's nucleus, its core, in order to capture the energy released and relieves you with a new atom as a byproduct. The energy produced in such reactions is procured in the form of heat, which is then taken out of the core by use of coolant. Then the coolant carries the heat to a water source where it is heated and boiled to create steam and turn a fan that generates electricity. The largest plant in the world resides in Palo Verde, Arizona, and with 3 reactors able to generate 3,937 megawatts that it uses to supply power to 4 million people. On a grand scale, nuclear energy only makes up 19.7% of our power consumption in the United States, but there are also only 30 states with nuclear reactors working currently. Though the reactions are subatomic, the impact is worldwide to both the Earth and everything living on it. Nuclear power is a highly possible alternative for the future generating of electricity, which supports greatly reduced emissions and the possibility of waste being recycled. Massive energy output is created through the processes in nuclear power plants, and it could help save our dying planet in the process. Nuclear fission is very efficient at producing energy, but the potential of nuclear fusion is even greater. Fusing two small atoms together to create one larger atom produces an even more immense amount of energy than nuclear fission does, but at the same time it requires immense heat and pressure, such as conditions in our sun, and possibly holds the key to unlocking potential limitless energy.
That